All right, after a brief introduction, what we're doing is, and I told them we're gonna have a quiz on this story geometry on Monday. We're doing problem number 8 on the homework sheet. All right, zinc plus what? What's zinc gonna react with? Who's gonna call him? Isabella, you know. What's zinc gonna react with?
Nitrogen.
Say it again. Nitrogen, let's take a look. It says here a hydrogen gas will be produced. What does that mean? Hydrogen gas will be produced. What side of the arrow are you going to put on it if it's produced? To the right. So we know that hydrogen gas, now why did I write H2? It's a diatomic element, isn't it? Okay. Now, does anybody know what this is? How to write this one? What do you think? Kyle, you know? Zach, you know? Danny, you know? No. It says here it's going to react, zinc's going to react with nitric acid. What do you know about acids? They always start with what element? H. And nitric acid has a famous nitrate in it. Nitrate's -1, hydrogen's +1. I will tell you that in most cases, I will give you the equation. You'll still have to balance it. You get that? Now, the author, this is a kind of a stretch question because notice if I write this down, do you notice there's something different? There's something wrong about this? There's something not right yet. What do you see? What's wrong? It said it was a single replacement reaction. And you actually were very good when we had that chapter and you had to classify things. Remember that? If this is single replacement, then what's going to be formed here? Who got kicked out? Who is zinc going to kick out? Is it going to kick out this guy or this guy? Does zinc kick out this guy or this guy? What do you think? Is that right? So it's going to form a compound with hydrogen? So zinc is always going to be the positive ion. It's going to be written first, right? So this guy is going to kick out the first thing here. So he kicks out a hydrogen. It just happens, though, he has to wait a millionth of a second for another hydrogen to make H2. But it's going to make the second compound. What's the second thing? If I kick you out, I'm going to make zinc nitrate. Now, again, you have these skills. You have these skills, but we have to remember them, right? What's the charge on nitrate? And again, right over here, we had it right here. See this? What's the charge on nitrate? All right, what's the charge on zinc? Remember that? Remember that? Remember these are always +1. These are always +2. And then you have silver, zinc, aluminum, +1, +2, +3. Remember that? So what's zinc? +2. Now, how do you fix that? How do we fix that? I have +2 and -1. Everybody know how to fix it? Are you okay on that? Now, this chemical is written correctly. That's written correctly. That's written correctly. And now we can balance it. All right. Everybody know how to balance it? Let's try it. Go ahead and balance it. Scan, 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 scan. 2 nitrates, 1 nitrate. 2 nitrates. 2 hydrogens, 2 hydrogens. 1 zinc, 1 zinc. Okay. Did anybody get close to that? Everybody? Is it, all right. So maybe you need a little help on that, didn't you? So now let's do the stuff we're doing this chapter. This is actually old stuff, and you can tell yourself, you know, I'm still a little weak on that. But let's do the new stuff. What a volume of 7.5 liters of hydrogen gas. Now, I'm not going to write that down here. What's the only thing I ever write below the balance equation? What world are you in if you're down here? The mole world. So I'm not going to put it up here. I'm going to put it up here because it's not moles. So I'm going to put 7.5 liters. Everybody got it? All right. Now, what do they want me to find? A volume of 7.5 liters of hydrogen gas at STP was produced from a single replacement reaction of zinc and nitric acid. Calculate the mass of zinc. You see how this is organized? if you do what I was asking you to do, then I know I know that I have to go from here over to here, don't I? But I can't go right here because there's a tree in the way. Remember the chemistry? So what's my plan? My plan is I'll need to go down into change what? Liters of hydrogen into, say it. Everybody say it. Moles of hydrogen, and then change moles of hydrogen to what? Moles of zinc, and then change moles of zinc. I can do that. See, to me, if you write this out and you have a plan, I know I'm going to have 1 step, 2 steps, 3 steps, and I'll be done. Okay, so we're going to go slow as I have to go until you said, I got this now. I've got this. All right, let's write the given. That should not be a problem, okay? Now, what I need to do is, we know we're going to change liters of hydrogen into moles. So what goes down here? Hey, I'm getting used to this. I can do that. All right, now here we go. I need some numbers, don't I? Who wants to show off a little bit? Madison, you do. Madison, tell me everything you know about H2. I'll start you out. Molecules equals what? Yes. And we learned something new yesterday. We learned something new. A gas at standard temperature and pressure, 1 mole of any gas takes up how much space? Right there. That's the new thing from yesterday, right? Now, guess what? I can do this. I can do it. There's my little toolbox, right? All I need to say, what if this is equal to that? And you go down here and you say, there it is, 1. 1 mole of hydrogen gas is the same as, there it is, 22.4. Now what I'm going to do here is, I'm not put equals, I'm not going to do equals right now. I'm going to have you write the number in here, and then we're going to keep on going, all right? So get your calculators out, and remember, don't go below 3 sig figs. I know they only gave me 2 here, but we're going to try to stay at 3 sig figs. So everybody see what you're doing then? 7.5, you're going to divide it by 22.4, right? Let's do that. When you get finished, look at your neighbor. What'd you get? What'd you get? If you got the same thing, you match. Delaney, I don't know if you've been watching the videos, Delaney. Have you been watching the videos at all?
Watched a little bit of them yesterday.
Okay, now we had that 22.4 thing yesterday. So you might need a little more help today. All right, Julie, what'd you get?
0.335. Oh,
No, can't be that big.
0.335.
Oh, 0.335? And that's liters, right? I mean, that's moles. Did everybody get 0.335? All right, so this, are you okay so far? You said, I can do this. See, if you're confident, you said, I can do that. I'm pretty good at this. I can do it. Now, in words, tell me what you want to do. What do you think, Zach? Tell me in words, what do you want to do? Say it in words. Change. Remember this, the mole world? Underground? Say it. Change moles of what? And change it to what? Yes. And that's how I know how to do factor label. I want to change moles of hydrogen, that goes down here, into moles of zinc. Okay, now, Zach, let's see if you remember this from yesterday, and the day before, and the day before. Where do you get the numbers? And don't ask May, because she knows. Where do you get the numbers when you go sideways in the mole world? Where do you get your numbers? Don't ask May. Yeah, well, not these equivalents. We get them from somewhere else now. When you go sideways in the mole world, okay, ask May.
Coefficient.
Right. So this balanced equation, that's why now watch here, it says here, for every one of these, for every one of those, there's what? one of those. Now, I know that sounds like a waste of time, but we had to put that in there. So this is also going to be 0.335. And we'll do the shortcut again, okay? I'll show you the shortcut after this. Are you okay so far? See, if you just tell me, you said, no, I'm not okay here, then I won't move on. All right, so now, ready? Who can I call on? Madison, ready? I have one more step, Madison. Say it in words. I'm going to change what into what? Moles of zinc to grams. That's exactly right. Moles of zinc into grams of zinc. And what do I know about zinc? Daniel, tell me everything you know about zinc. Wait, 1 mole of zinc equals
6.02 times 10 to the 23
atoms of zinc
and
equals,
65.3 grams.
and I can't use the STP thing because it's not a gas. That's only for gases, isn't it? This is not a gas, is it? So I can't use the 22.4 here. So I'm done. I'm done with that. Everybody with me? All right, now here we go. Tell me what goes here. 1 mole of zinc is the same as, there it is, 65.3 grams of zinc. And now I should be able to finish the problem now. All right, everybody put that in there. And it should be 0.335 times 65.3. So it's going to be, if I had to guess, so between 20 and 30, 20 and 25. Yes.
I don't have my calculator with me, so it's at home. So can I use my phone for my calculator?
Yeah, sure. Definitely, everybody should be trying these out, because otherwise you won't know if you could do it. All right, Kyle, tell me the answer. 21 point what? 876. Okay, so I'll go 88. How about that? Did everybody get something like that? Did everybody get something like 21.88? All right, now tell me right now, what is it about this? I agree, we struggled a little bit coming up with the balanced equation. Is that correct? But most of the time, I'll give you the equation. You might have to balance it, but most of the time, I'll give you the equation. So can you do this, you think? If I give you a quiz right now, I'm not going to. If I give you a quiz right now, could you do it? Even if it had to do with a gas, right? All right. Let's review shortcut. Let me show you shortcut. On the quiz, I'm going to make you show your work. You get that? But if you want to check your work, you can do shortcut. And when you take the test, I'm not going to ask you to show your work. On the test, you can do shortcut all the time. Get it? All right, so let me show you how to do the shortcut one more time. And let's pretend like all these numbers are gone. All the numbers have disappeared. Are you ready? Now, the only shortcut you don't know about this one is that guy right there, but we can do that too. Excuse me. Let's see how I can do this. I just thought about my shortcut. Normally I start with the grams up here on the shortcut. Can I try something weird? Can I do the problem backwards? Can I act like this was given? Can we pretend like this was given and I want to know how many liters? Can we do that? Let's try it. Ready? Here's a shortcut. When you're up here in grams, if you want to go down in the mole world, what do? You divide by the molar mass of zinc. What's the molar mass of zinc? Let's do that now. Ready? When you go down in the mole world, you divide by the molar mass of zinc. So take 21.88 and divide by the molar mass of zinc. And see if you did you get 0.335 or something like that? Now, watch this. In this case, I'm actually going from here this way. Okay, now, watch what happens. When I go this way, I look at the coefficients, don't I? Now, watch what's going to happen here. 1, 1. What if this was a 2? That'd be a 2. What if this was 10? That had to be 10. What if this was 0.335? What's this have to be? That's a matchy-matchy, isn't it? Can you tell me what number this would have been? How many moles of that? Well, I'm going to show you a shortcut. Ready? If you're going from here to there, number one, gotta get bigger. Gotta get bigger. Now you have a choice. What do you want to multiply this by to make it bigger? 1 over 2 or 2 over 1? Which one makes you bigger? 2 over 1. Now take that number there times 2 and tell me what you get. Is that what you got? Did you get 0.370? Now this problem doesn't ask me to find out how many moles of nitric acid, but I did. I did, didn't I? What about over here? What if I ask you on the shortcut to tell me how many moles of zinc nitrate were going to be made? Oh, well, wait a minute. 1, 1, 1, matchy, matchy, matchy. If this is 0.335, this got to be 0.335. And see that? That's the shortcut. All right. Okay, then, what about this one? How do you go up? Normally, let's go up and change it to grams. How do you normally go up out of the mole world? When you want to go up out of the mole world, you multiply by the molar mass of H2. Let's try that right now. Right? Put 0.335 and multiply it by the molar mass of H2, which is 2, which would be wait, that's not right. Not 0.3. What did I say? It should be 0.670. Is that right? Sorry. So, what if I had asked you to tell me how many grams of hydrogen were made? I can do it right there, can't I? And so what I like about this is that once you know why the long cut works, then the shortcut really becomes your friend. You can do these kind of quickly, like that. All right, we're going to try one more, okay? And you're going to sit with somebody. And what I'm going to do is I'm going to ask you to complete the equation and tell me all the moles and tell me all the grams. So we're going to try one more practice problem, and then we're going to move on. All right, let's see. I don't know if I like that equation. Let's see. I need a better one to practice with. Okay, there's one. I like this one. All right, now this one's, what I'm going to do is I'm going to give you one of these numbers, and then what you're going to do is you're going to find out everything else. Now, so I want you to find this, grams. I want you to find this in grams. I want you to find this in grams, and this in grams, and I want you to find all the moles. Now, you're going to be sitting with somebody. And so the first thing you have to do with stoichiometry is have a balanced equation. So I need some help. Before you get a partner, tell me how to balance this equation. This is a little bit more difficult. Anybody want to take a stab at it? What do you think? Who wants to try it? I do notice one thing here. There are 3 hydrogens here, but only 2 here, right? That's like an odd even mismatch. So you want to try that? Can we put a 3 here and a 2 here? Will that help a little bit? Does that give me 6 hydrogens and 6 hydrogens? I like that. Now, how many nitrogens does that give me? 2, 2. Hey, pretty good. How many oxygens does that give me, though? How many oxygens? 3, but I only have 1 here. But how many coppers does that give me? 3. All right, I like this one because it has a lot of coefficients in it, doesn't it? All right, I'd like you to sit with somebody, and we're not. Would you like to try the shortcut first, or you want to do the long cut? You guys, yes, you want to do shortcut, or you want to try the long cut? Yeah, tell me. The quiz is on long cut, but.
Can we try the shortcut first?
All right, let's do that. Now, are you sure you understand the shortcut? Can I give an example? Can I give you an example? Watch here. What if you have a number right there, and you want to go here? Here's the shortcut. Watch. Watch up here. Ready? 2, 3. Gotta get bigger. Gotta get bigger. So what are you going to multiply this to get bigger? 2/3 or 3/2? Which one makes you bigger?
3/2.
It does. So here I'd multiply by 3/2. Okay? Let's try another one. What if you're going from here to here? 2, 1. 2, 1. Gotta get what?
Bigger.
No. 2, 1. Gotta get.
Smaller.
Now, so what number is going to make you smaller? 2 over 1 or 1 over 2? So you're going to multiply by 1/2, see? Look at this one. How about go from here to here? Matchy. See? Matchy. Whatever you get for that number, here. See? Now, you all right? All right, go find a partner. I'm going to walk around the room. You find a partner or two, and make sure that they know how to use the shortcut, but then we'll do some long cut too. So give yourself some space to put all these numbers in, okay? All right, you have to be a good teacher, okay? Because you haven't been here. So give it over. You got to be a really good teacher. Give you a hint. If you want a shortcut, you might as well put all the molar masses. You might as well go ahead and figure out all the molar masses while you're sitting there, okay? That's what I do.
18 creepers. Oh my gosh.
What I would do is
17.
yeah, 14 over 3 equals 17. Plus 6 is like, let's do the next one. Again, 2, that's the easy one. And 2. 28. Let's do the next one. Copper by itself. That's 63.5. That's 4. That's easy. By itself. 63.5. Now we have all the molar masses. And now we're saying something. You know the brown is the divide by the molar masses. So you want to divide by 7. Now let's try this for this one. Let's say,
What's she trying to do?
I know, well, you can leave it. I'm just rounding off.
Yeah, okay, so then I'll try to find that, but I just.
Define that box, and then they go out and you multiply that.
So that was
Oh, the second one? It's the
Okay.
same.
the second one is the same. I made you a mess. That one's, I didn't know it's not 27.
He ended up three then?
Now.
And then three, so you.
That's right. You got a good handle now. You have a good handle. Yes.
So when you find this.
Right,
it's gonna be 3 times bigger.
Here's what I'm gonna do, you guys, damn, you guys are so good at this, I want you to come over here and teach these. Okay?
If it wasn't bigger, you would do one every three.
You like shortcut or not?
And then this.
I'm fine, I'll do a long cut, I'll do a long cut. We'll do a shortcut, just so you can check your answers, how about that? We'll do a long cut. Hey, guys, as soon as you get finished, Daniel, as soon as you get finished, come over here and teach us. All right. Great, great, everyone, more math. Now, this one should be 63.5 plus 16, put that out there somewhere. 63.5 plus 16, so I know it's not gonna be 8. Oh. 9.5, okay, that's minor, I'm not worried about that, that's minor. And again, this is 63.5. So let me take a look at this. I give you that.
Actually, we can check it.
Okay, so ready, you can put the denominator, or we divide by the more mass of NH3.
Oh, no, it's 18. If you do 1.065 times the molar mass is.
One point oh six. And then the size of the animal, we look coefficient from 2, 3. 2 that gets bigger, doesn't it? So multiply by 3 right now. You see that? Put that down. Now, good news, when I'm going sideways, I'm ready to move it on the side. Wait, these two are, because they had 3, so you're right, but not this one. Okay, now, how do we get, how do we? I like to put them on. I don't know why you do this. Now, see this? Look at 3, 1, 3, 1. 3 is what I think it. You go down from 3 to 1, that's getting bigger. It's like, getting smaller, right? So we're gonna multiply to make something else happen. You have a choice. We can't go this one over here. 1.59 times a third.
I did it last year. I just did it.
Easy part is here. On other however mole, we don't plus however mole. Whenever you go up and down, take a look at this. So this right here is 9, that. And this right here. Alright, you have a good hand. Alright. Alright, 2 groups. If you teach them we'll do the long cut in a minute, but show them the shortcut, okay? Alright, so let's take a look. This is a given, right? So, now, my only thing is, you have to put your molar masses right on. That's what I mentioned. I mentioned, you have to have your molar masses. What's the molar mass?
NH3 would be like.
What's the molar mass of this? What is it? Alright, 14 plus 3, 15 grams. What's the molar mass of this?
Find a molar mass of.
So, let's say 63 what is the molar mass of water if it's in another
What you do
equation?
is you multiply by the mass, right?
So whenever you do molar mass, you don't necessarily go. Matter of fact, when you do stoichiometry, we're going to go up and down in the world. I never look at the coefficient. When I go sideways, I only look at the coefficient. So here we go. Ready for a thought? See where you're already here. Okay, I'm gonna show you that. Now, we can do the long cut. We did that last chapter. You're certified, but I'll show you how to do it forward. You want to go down the molar road and divide by the molar mass. So you did 18.1 divided by, and that's how you got the number right. Now, you put grams here. That's a mistake. Let me process for you. And I'll put this down here. The mole world. Okay. Now, what I'm gonna do here is I'm gonna go from here to here, don't I? So you already did that, guys. Now watch, when you go sideways in the world, you can only look at the coefficient. How can the number 2 become the number 3? Gotta get bigger. Now, gotta get bigger. Your choice are multiply by 2 over 3 or 3 over 2. Which number is gonna make you bigger? Wait, think about that.
Kyle, listen.
What's that one? Ow! You only get 2 choices, 2 over 3 or 3 over 2. Which one, if you multiply, will make you bigger? That's right. Because 3 over 2 is 1 1/2, isn't it? Isn't 3 over 2 1 1/2? That'll make you bigger. Now, so do that. 1.065 times 3 halves. Where'd you get that number from? Oh, matchy. What's this? 1.065 times 3 halves. Come on. Okay. Wait. 1.60, okay, good. That's 3/6, right? Did you get that? You should be punching those buttons. Now, here's the fun part. You see, I'm gonna go sideways, and I gotta get this one. But look, when I go sideways,
Right.
look at the coefficients, look at that. The ratio of 3 to 3, that's a matchy. So, see now, whatever that is, that also has to be equal to this. And look at that, matchy. See that? That was easy. Now this is one, it's not easy. Ready? 3, 1. 3, gotta get smaller to go to 1. So what are you gonna multiply by to make it smaller? You get a choice, 3 over 1 or 1 over 3. What's 1.60? Take that number right there, times 130. Not 3, you got this from here. If you multiply something by 3, it's bigger. 5.3. Now, that's the hard part. Now, the easy part is you're gonna multiply, you're gonna get up out of the mole world. You multiply by the mole world. You ready? Got a calculator? This addition sits already in there. Multiply by the molar mass of N2. And then multiply this one times the molar mass of Cu. That's the easy part.
Now, what do you get?
How do I get the grams?
You multiply this, the moles, by the mole mass in order to.
Whenever you go up and down in the mole world, you have to use molar mass. But when you go sideways, you use the coefficients. That's something to delete.
Okay.
Now, can I tell you something? We'll go back into the long cut, but if you understand the long cut, you actually know why the shortcut works. You know why matchy works? The long cut makes me put 3 moles of this for every 3 moles of that. And that's like multiplying by 1. 3 over 3 is like 1. That's why it's a matchy. All right, what do you think? What do you think? All right, let me, let's go back up here. All right, here we go. Now, what I'm going to do is, even though I'm going to do shortcut right away, I'm going to also do one of these. I'm going to pick one at random, and we're going to do the long cut. Everybody get it? All right, here we go. start right here. Madison, you help me out. You're gonna start. When you wanna go, yeah. Oh, you want me to wait? Okay, okay.
I'm fine, I'm just telling her, or telling her.
Okay, is it okay if I get her to give me an answer?
I don't have it.
Okay. But you can watch me do it also. Madison, when the shortcut says when you want to go, oh, by the way, can I help me out here? I need some molar masses. And the molar mass of NH3 is 14 plus 3, 17. And what's the molar mass of CuO? What was that, 79.5 grams? Okay, what's the molar mass of N2? 28, let's see, 14 and 14. The molar mass of Cu is 63.5, and the molar mass of H2O is 18 grams. All right, is everybody ready to go? Madison, when you want to go down in the mole world, you divide by the molar mass of NH3. And notice I did not look at coefficients. Look at me. When I go up and down, I do not look at coefficients. I only look at coefficients when I slide sideways. You get that? All right, what do you got here?
1.065.
Okay, and I'm okay if somebody round to 1.07. I'm okay with that, okay? Now, watch. Are you okay with that? When you go down the mole world, divide by molar mass. We did it. Now, when you go sideways, watch right here. This is your pattern. The balance equation is your pattern. This number here is always going to be bigger than that number, isn't it? So if I go from here to here, the number's got to get bigger, doesn't it? Now you have a choice. You multiply by 3 over 2 or 2 over 3. One of those will make you bigger. And it's 3 over 2. All right, Madison, one more and I'll be done with you, okay? What do you get here?
1.60.
1 point what?
60.
Okay. Does everybody get something like that? I'm all right if you're off by a little tiny bit. I'm okay with that. Is everybody okay so far? All right, now, the really neat part about this is when you have 3, 3, and 3. Got to get the same. Doesn't it have to be the same? If that's 3, that has to be 3. If that's 9, that has to be 9. If this is 1.60, what's this have to be? 1.60, what's this have to be? All right. All right. All right, let's go over here to Kyle. Kyle, here's the hard part. I want to go from here to here. I want to go from here to here. So I go up here and look at the coefficients of what I had to do. I had to get bigger or smaller. And so what am I going to multiply? 1 over 3 or 3 over 1? All right, what'd you get? And again, if you're off by a little bit because you round it, hey, listen up, you round it a little bit differently. If you got something a little bit different, I'm okay with that. So now, we have done everything in the mole world, haven't we? And now the easy part is, how do you come up out of the mole world? How do you change moles back into grams using shortcut? You multiply by the molar mass. Okay, now, every year, even in the honors class, they ask this question. When I'm coming up, do I look at the coefficient? No. When I go up and down the mole world, I never look at the coefficient. I only look at it when I'm going sideways. So, watch here. 1.60 times the molar mass of that. Here we go. 1.60 times 79.5. Put that in there. May, what do you have?
Let's see. 126.4.
Okay. Now do the next one. This one, multiply by the molar mass of N2, 28. What's this times 28? Did you have time to do that one yet?
I'm 40.8.
How much?
14.8.
Okay. All right, that sounds right.
Yes.
All right, and let's switch over to Julie. Julia, how about, what do you have here? Multiply by the molar mass of copper, so this times 63.5.
102.6.
Point what?
0.6.
Okay, and do the last one for me also, okay? Multiply by the molar mass of water.
28.8.
28 point what?
0.8.
All right, now, what did I tell you a couple days ago and yesterday? How do you know you didn't make a big mistake on all of this? How can we check? It takes us about 30 seconds to check.
You
All right, see the arrow? Give me the grams. I want right now. That's one of my quiz questions anyway. What's the total mass of the reactants? Tell me that. What's the total mass of the reactants right now? What's the total mass of the reactants? Aurora, what do you have?
Oh, I'm doing it right now.
Okay. Does anybody have it? Uh-oh. Point two. Okay. Now I'm going to check that with this right here, and it could be off by a little bit because of rounding. But what's the total mass? What's the total mass of the products? Just tell me when you have it. Add this to this to this. Anybody have it? You already have it?
Yeah, it's the same.
Is it exactly the same? Even after rounding?
One's 2, one's 3, like 0.2, 0.3.
Oh man, that's it. See, what's the chance that we made a big mistake here? I don't think we did we? I'm not, because of rounding, they might be off by a tiny bit, but that's really the same number. See that? All right, what do you think? Now, what you mentioned, I'm going to do that. I am going to go and do a long cut. Here's what I'm going to ask you right now. From this problem here, I'm going to ask you to tell me something else. I want to know how many liters of N2 were produced at STP. How many liters were produced? I say, well, I forgot that shortcut. That's what I think. If you forgot the shortcut, what are you going to fall back on? We're going to fall back on factor label. All right. How do we do this right here? How do we find liters of N2? Now, I'll give you a choice. The fastest way is to go from the mole world to liters. But if you want, I can go from here to liters. I can go either one. I can go from here to liters or moles to liters, okay? The shortcut involves moles to liters. So let's try that. My given is 0.537 moles of N2. Remember, if you forget the shortcut, you have to have something to fall back on, don't you? All right, now what I'm going to do is I'm going to try to change that moles of N2 into liters of N2. All right, now you say to yourself, I don't know how to do that. Okay, tell me everything you know about N2. 1 mole of N2 is 6.02 times 10 to the 23rd molecules of N2 equals, help me out. Help me out, come on.
28.
28 what?
28.
Say grams.
G.
Molar mass is how many grams it takes to make a mole. And at STP, at standard temperature and pressure, 1 mole of any gas is 22.4 liters. Now you see that? That's my toolbox. And what do you want to do? I want to change moles of N2. 1 mole of N2 is the same as what? So what's the shortcut? The shortcut is moles times 22.4 gives you liters, doesn't it? Isn't that right? But if you forgot the shortcut, I can go back and do it this way, can't I? You have to trust me on that. You can't go to a test and only have shortcut, because all of a sudden if the shortcut disappears, you're gone. You have nothing. Isn't that right? You have to have something to fall back on. That's why on the quiz I'll make you do long cut. But you can check your work with shortcut, can't you? All right. So what I'm going to do, I'm not going to give you quiz, okay? But what I'm going to do is, you cannot do the backside of this. You get it? You will not know how to do the backside of this until Monday. So don't even look at the backside. You get it? I will eventually give you credit for this, but I want you to take this home. And I want you can use a shortcut to do these, but then you have to show your work down here. You get that? So everybody's going to take this home, and you're going to say, for Monday, I'm going to try to do all these, and I'll tell you what, I just thought about something. Brian, can you give us our numbers, please? I'm gonna help you out a little bit, okay? I need to help you out a little bit. Let me, help you balance the equation. See, do you know what's gonna happen if you take this home with the weekend and you have the wrong balance equation? Every one of the numbers are wrong. You get that? So what I'm gonna do is I'm gonna help you balance the equation, and then that'll be it for today. All right, lithium hydroxide is gonna react with carbon dioxide. They use this for astronauts. When they're up in space and they breathe out all the time, they can't allow the carbon dioxide to build up in the cabin. So they actually use this chemical right here, lithium hydroxide, and it absorbs carbon dioxide. And it keeps them from getting killed. And it forms a compound called lithium carbonate and water. Okay, now, do you see what I'm talking about, where the space is, where to put this? Does everybody see, can everybody see where to put that right there? Okay, now, let's balance it. Let's balance the equation, okay? All right, ready? Help me out. We gotta go here in about a minute. How are we gonna balance this? What do you notice? What's the first thing you notice? I'm not gonna balance oxygens first. They're everywhere. So what am I gonna do here? Lithium, yes, I see that. Let's try it. I'll put a little faint too. I might have to change it, we'll see. But now, so that gives me that. Now, how many hydrogens does that give me? 2. Oh, that looks good. And now, watch the number of oxygens. Watch. 2 oxygens plus 2 more is how many? 4. 3 plus 1. Whoa, that's 4. 1 carbon. 1 carbon. Yeah. Oh, yeah. All right. So is everybody okay on that? That was good news on that. Now, be honest. Please be honest. Don't copy somebody's work. Tell yourself, I can go home. I'm going to try. I might try the shortcut up here. See that? But then I'm going to do the factor label long cut here. You okay? And I'll even help you when you get back. But don't even think about the back. Don't do the back side at all. You get that? You're not ready for the back side, that's for sure. All right, well, thank you very much. You have a nice weekend. Have a nice weekend.